Good morning, everyone. Today I will introduce my research determination of chlorogenic acid concentration in coffee solution using NIR transmittance spectrum. The outline of my today's presentation includes 5 parts. The first part is the introduction. I will introduce the function of CJ in coffee solution, and also the problem to detect coffee solution in NIR region. The second part is the objective of my research, determine CJ concentration in coffee solution using NIR transmittance spectrum. And the third part is the material and the method. I will introduce the device and the experiment process, then followed by result and discussion, finally the future work. As we all know that coffee is one of the most popular beverages all over the world. Chlorogenic acid is one of the main phenolic compounds contained in coffee. This is the molecular structure. This is the molecular structure of chlorogenic acid. And the chlorogenic acid has antioxidant properties. It can prevent body cells from oxidant. It plays an important role on healthy diet. It can prevent people from radiation harm. It also contributes to the formation of coffee flavor such as acidity and bitterness. So based on these functions, to determine CJ concentration in coffee solution become necessary. In this study, I want to use NIR spectroscopy to detect coffee solution. But for solution detection in NIR region, water is the most serious interference because water has strong absorption in NIR region. This finger shows the water absorption in NIR region. From this finger, we can see that water has 2 strong and broad absorption peaks in NIR region. And this 2 peaks is caused by OH bond motions in water. Usually, water absorption is much higher than sample in this experiment, much higher than CJ. So, how to remove water interference and extract sample informative spectrum become important. For previous research, usually they use mathematical method to remove the water interference, such as second derivative method was used to process spectra of juice, and region or signal correction method was used to remove the interference signal of water from NIR spectra of blood glucose. And moving window partial least square regression method was used to find the informative spectra from the NIR spectra of serum solution. So the objective of my research is to find a good experimental way or mathematical method to remove the water interference, and also develop a model to determine CJ concentration in coffee solution using NIR transmittance spectrum. Before I measure the coffee solution, the first step, I want to measure the pure CJ solution in NIR region to find the characteristic absorption peak of pure CJ in NIR region. This is the device I use in my experiment, UV NIR spectrometer. And inside it contains 2 beams. One is for sample detection and one is for reference. In this experiment, the sample is a CJ water solution, and the reference I choose the pure distilled water. Then I get the CJ spectrum. Ideally, the spectrum should just represent CJ information because water information has already been removed, as we're using water as a reference. From the result, we can see that some of absorption value is negative. This is because water has strong absorption in these 2 regions. We can see that water absorption is more than 1.5, and the CJA absorption is just 0.02. So compared to the reference pure water, our sample CJA water solution contains less water concentration, so the absorption of sample is lower than reference. Then the spectrum becomes negative. Also, water strong absorption can enlarge the device unstable noise. So anyway, we can conclude that the CJ spectrum we get from using water as a solvent, it may contain a lot of noise caused by water. So in order to eliminate this noise, we need to find a solvent which doesn't have absorption in NIR region. But unfortunately, I haven't found such a solvent to dissolve CJ so far. Then I tried acetone. CJ is easily dissolved in acetone, and this is the molecular structure of acetone. From the structure, we can see that acetone doesn't contain the OH bond. So compared to water, in these two water strong absorption region, acetone absorption is very low. So it means if we use acetone as a solvent, in this region, the CJ spectra may contain less noise. Then I use acetone to conduct the experiment again. This time, CJ acetone solution were used as sample and the acetone were used as a reference. Then we can get the CJ spectrum again. This is a different concentration of CJ spectrum. The up finger is the CJ spectrum we get from using acetone as a solvent, and the finger below is the pure acetone spectrum. We already know that acetone has low absorption in these two regions, so corresponding to these two regions, CJ spectrum in these two regions contain the least noise. But in other regions, such as this part, acetone absorption is strong. So in this part, the CJ spectra contain noise. Then, in order to extract the accurate CJ spectrum, I combine the CJ spectra get from using water as a solvent and acetone as a solvent. Then I will show how I combine the spectrum. This is the CJ spectrum we get from using water as a solvent. We already know that in these two regions, it contains a lot of noise because water strong effect. So I removed these two regions and then replace these two regions using the CJ spectrum I get from using acetone as a solvent. Then I get the accurate CJ spectrum. And because after 2100 nanometers for acetone and water, both are strong absorption. So after this wavelength, I removed. Then future work, I will get the NIR transmittance spectrum of coffee solution, and different mathematical methods will be tried to pre-process the original spectrum to remove water interference or extract the informative information. And then we can evaluate the different pre-processing methods. And also we can explain the final regression model comparing to the CJ spectrum we just get. That's all. Thank you.
Any suggestion? Comment?
You measure CJ solution by using the pure water as a reference.
Yes.
So is it popular in the NIR measurement?
Usually For previous research, they just use air as reference. But I think use water as reference is better because water information will be removed.
If you had pure distilled water in both your reference and your sample cells in the dual beam, do you get a perfectly flat signal?
No. You mean use water as sample and water as reference?
Yes.
No. The baseline not zero.
Not zero.
A little flat.
So it is the instrumental, the noise is,
yes.
in theory, if you are subtracting your reference from your sample and both are the same, it should be flat.
Yes. But because the device maybe contain noise.
So it's related to the cell, quality of the cells, or
maybe the light source, maybe not unstable, maybe black.
So did you measure the individual difference between the spectra? The individual difference. I think it's better if so you measure the individual difference of the spectra. You average from what? That spectra. How many times you average?
Just one.
Any other suggestions? Comments?
In your graph with both with the water and with the acetone, you showed that there are areas where there is minimal noise. Why do you not restrict your analysis to that area alone? Why do you want to get a broad spectrum analysis?
Broad spectrum.
So in this one here, between 1,400 and 1,600, is a zone where there is minimal interference.
Yes.
Why don't you just do your analysis in that wavelength only?
I haven't tried. Maybe I should try.
Anyone else? Okay, nothing. Yeah, try more. Okay. Yes. Okay, thank you very much.